Good afternoon, everyone. So today we will solve exercise 9.3 from question 1 to 10 of differential equation. Okay. So question number 1 is find the general solution of dy by dx is equal to 1 minus cos x by 1 plus cos x. As we already covered the theory portion of how to find the solution of a differential equation using method of variable separable. Okay. So if a given differential equation is first order and first degree and it is of the form dy by dx is equal to gx into hy, then we can separate the variable as 1 by hy dy is equal to gx dx, and then we integrate and find the general solution of the differential equation. So as here the given differential equation is dy by dx is equal to 1 minus cos x by 1 plus cos x. The highest order derivative present is dy by dx, so order is 1, and as the highest power of dy by dx is 1, so this given differential equation is of first order and first degree kind. And also we can separate the variable here, so just try to solve this differential equation by using variable separable method. So the given differential equation is dy by dx is equal to 1 minus cos x by 1 plus cos x, and we know that cos x is equal to 1 minus 2 sin square x by 2. So 1 minus cos x can be written as 2 sin square x by 2, and 1 plus cos x can be written as 2 cos square x by 2. So by using this above formula, the differential equation dy by dx is equal to 1 minus cos x by 1 plus cos x become 2 sin square x by 2 by 2 cos square x by 2. So as we know, sin x by cos x is 10x, so sin square x by 2 and cos square x by 2 become 10 square x by 2. Now we can write 10 square x by 2 as sec square x by 2 minus 1. So now we separate the variable. So on separating the variable, we have dy is equal to sec square x by 2 minus 1 dx. Okay, so when we separating the variable, we write the terms involving x with dx and the terms involving y with dy. So when we separate the variable, so on integrating both sides of the above differential equation, we have integrate dy and then integration of sec square x by 2 minus 1 dx. So just separate the integral sign, so integral sec square x by 2 dx minus integral of dx, and we know that integration of sec square x by 2 is 210 x by 2. So using this, the above equation become the integration of dy is y and integration of sec square x by 2 is 210 x by 2, and integration of dx is x plus constant of integration c, and that is your required general solution of the given differential equation. So whenever we solve a differential equation, we get a solution with arbitrary constant, and that solution is general solution which represent a family of curves. Okay, and by using the some initial condition, when we remove that constant, we get a particular solution of a differential equation which represent a single curve which satisfy the differential equation and also the initial condition. Now question 2 is find the general solution. The differential equation is dy by dx is equal to root under 4 minus y square and y varies from minus 2 to 2. Okay, so just apply the variable separable method. So just separate the variable and then integrate to find the solution. So the given differential equation is dy by dx is equal to root under 4 minus y square. So it is of the form dy by dx is equal to gx into hy, as here the function gx is constant 1 and hy is root under 4 minus y square. So we can apply the variable separable method. We write the function with y with dy. So we get dy by root under 4 minus y square. We take the 4 root under 4 minus y square from the left hand side to the right hand side with dy is equal to dx. Now we have to integrate this so that we can find the solution. So when we integrate, so integration of dy by root under 4 minus y square, integration of dx. Now to find the integration of dy by root under 4 minus y square, this is a standard form, a special case of integral, and we already know the formula to integrate dy by root under 4 minus y square. That is, the integral of dy by root under a square minus y square is sine inverse y by a. Okay, so just use this formula. The integration of dy by root under 4 minus y square become sine inverse y by 2, as the value of a is 2, and integration of dx is x plus c. So we get y by 2 is equal to sine, we take sine inverse to the left right hand side, so it becomes sine x plus c. Therefore the general solution of the given differential equation is y is equal to 2 sine x plus c. Clear? Now question number 3 is find the general solution of the given differential equation dy by dx plus y is equal to 1 and y is not equal to 1. Okay, that's your differential equation of first order and first degree. So we can apply a variable separable method to solve this differential equation. So just try. So the given differential equation is dy by dx plus y is equal to 1. So we just multiply both sides by dx. We have dy plus y dx is equal to dx. Okay, we just try to separate the variables. We write the terms with x with dx and terms involving the variable y with dy. So we take y dx from the left hand side to the right hand side so that we club the term with dx. So dy is equal to 1 minus y dx. We just take the common from y dx and dx. So after separating the variable, as we can see here, there is an equation that is dy is equal to 1 minus y dx. So the term 1 minus y should be on the left hand side with dy. So when we separate the variables, we get dy by 1 minus y is equal to dx. Okay, so now we can integrate this expression to get the solution of the differential equation. So on integrating both sides of the above differential equation, we get integral of dy by 1 minus y is equal to integration of dx and as we know that integration of 1 by x dx is log mod x and integration of xn is x to the power n plus 1 by n plus 1. So on using the above formula, dy by 1 minus y is equal to integration of dx become, at first we integrate dy by 1 minus y. So we get minus log mod 1 minus y. So to integrate this, we can apply the substitution method and just take 1 minus y with another variable like t and then differentiate it. So we get d minus dy is equal to dt. And when we substitute back and apply the formula of integration of 1 by x dx, we get minus log 1 minus y. Okay, and integration of x is dx is x plus, here we take the constant of integration as log c. This is also an arbitrary constant. Why we take log c instead of just a simple c? Because now we want to apply the property of logarithmic so that our solution looks simpler. And we can modify the solution. So we take the log c on the left hand side, so it become minus log c minus log 1 minus y is equal to x. So we can apply the property of logarithmic on the left hand side. As we know, log m plus log n is log mn. So using this, we have log c 1 minus y is equal to minus x. We just multiply by the minus on both sides. So now we take log from the left hand side to the right hand side, it becomes exponential. So mod c 1 minus y is equal to e to the power minus x. And when we remove this mod sign, we get 1 minus y is equal to plus minus 1 by c e to the power minus x. If there is an equation that is mod x is equal to a, and if you want to remove that mod sign, the x is equal to plus minus a. Now from this equation, we want the value of y. So y is equal to 1 minus plus 1 by c e to the power minus x. Therefore, the general solution of the given differential equation is y is equal to 1 plus a into a to the power minus x, where a is the new arbitrary constant for minus plus 1 by c. And that is the solution of the given differential equation. Clear? Now question number 4 is, find the general solution of sec square x 10y dx plus sec square y 10x dy is equal to 0. So if you observe here, in the first term, there is sec square x 10y dx. Okay, so there is a term 10y with variable y, but it is with dx. And in the second term, there is sec square y 10x dy. So there is 10x with dy. So just separate the variable, write the terms involving x with dx and the term involving y with dy to apply the variable separable method. Okay, so try. The given differential equation is sec square x 10y dx plus sec square y 10x dy is equal to 0. So we dividing both side by 10x 10y. So we have sec square x 10y dx plus sec square y 10x dy by 10x 10y is equal to 0. Why we divide by 10x 10y? So that we can separate the variable as the x term with dx and the term with variable y with dy. So we get sec square x by 10x dx plus sec square y by 10y dy. Okay. So we can rewrite our differential equation as sec square x by 10x dx is equal to sec square y minus sec square y by 10y dy. So now we separate the variables. We write the terms with x, that is sec square x and 10x with dx, and the term with y, that is sec square y 10y with dy. So second step is we just differentiate, integrating both sides of this equation. We get integration of sec square x by 10x dx is equal to minus sec square y 10y dy plus log c. Log c is a constant. Okay, so now we have to find this value of this integral. So to integrate this, we apply the substitution method. Okay, so for the first part, for the left hand side, that is integration of sec square x by 10x dx, we just substitute 10x as equal to t. Why we take 10x as a new variable t? Because when we differentiating t, this expression 10x equal to with respect to x, we get dx by 10x is equal to sec square x. Okay, and sec square x is present on the numerator part, so we take 10x as a new variable t. Because of that, when we differentiate, we get d by dx 10x is equal to dt by dx, that is sec square x is equal to dt by dx. So we can write sec square x dx is equal to dt. Okay, so we can replace on the given integral, that is integral of sec square x dx is equal to 10x become integral of 1 by t dt. We write in place of sec square dx as dt, and for 10x we just replace it by t, the new variable. So my integral, by using the substitution method, it is log mod t. Now substitute back the value of t, so we get log mod 10x as the integration of sec square x by 10x dx. Similarly, we can find the integral of sec square y by 10y dy is equal to log 10y, log mod 10y. So substitute this value in the equation, that is integration of sec square x by 10x this is equal to integration minus integration of sec square by 10y dy plus log c. We get log mod 10x is equal to minus log mod 10y plus log c. Okay. So we take arbitrary constant as log c. Why? Because we can simplify or modify our solution by using this arbitrary constant. We can also take it as a simple c, but we take log c because by using of this log c we can apply the property of logarithmic and just modify the solution so it looks like simpler or more standard. So just apply the logarithmic property. So log 10x and log a minus log b is log a by b, so it become log mod c by 10y. As we know, log m by log n is log m by n. So it become mod 10x is equal to mod c by 10y. So we get 10x into 10, mod 10x into 10y is equal to mod c. Remove the mod, we get 10x into 10y is equal to plus minus c. So on reviewing with new arbitrary constant, we take capital C as a plus minus c. So the general solution of given differential equation is 10x into 10y is equal to c. Question number 5 is find the general solution of the differential equation ex plus e to the power minus x dy minus ex minus e to the power minus x dx is equal to 0. Okay, so just separate the variable same as we do in the previous questions. Write the terms involving x with dx, and if there is any terms with y, write it with dy and then integrate. Okay, so just try. The given differential equation is ex plus e minus e to the power minus x dy minus ex minus e to the power minus x dx is equal to 0. Okay, so there is a term ex plus e to the power minus x with dy, so we write it as ex plus e to the power minus x dy is equal to e to the power x minus e to the power minus x dx. So we take ex plus e to the power minus x, that is with dy, to the right hand side so that it is with dx. So we get ex minus e to the power minus x by ex plus e to the power minus x dx. So now we integrate, we just separate the variables. So we integrating both sides of this equation, we get integration of dy is equal to integration of ex minus e to the power minus x by ex plus e to the power minus x dx plus c. So now we have to find this integral. Okay, so we apply the substitution method to integrate this. Integral of dy is y so let ex plus e to the power minus x is equal to t as a new variable. Okay, Why we take it as new variable t? Because when we differentiating it both side with respect to t, with respect to x, we get, as we know, differentiation of ex with respect to x is ex, and differentiation of e to the power minus x is minus e to the power minus. So using this, we get differentiation of e to the power x plus e to the power minus x with respect to dx is equal to dt by dx. So that is ex minus e to the power minus x is equal to dt by dx. So e to the power x minus e to the power minus x dx is equal to dt. So substituting this value in equation, y is equal to integration of ex minus e to the power minus x by ex plus e to the power minus x dx plus c, we get, we just using the substitution method to integrate this, that is integration of ex minus e to the power minus x by ex plus e to the power minus x. So we write, in place of ex minus e to the power minus x dx is dt, and we substitute t for ex plus e to the power minus x. So we just get integration of 1 by t dt plus c. And we know that integration of 1 by t is log mod t. So using this, we have y is equal to log mod t plus c. So substitute back the value of t, that is ex plus e to the power minus x. So y is equal to log ex plus e to the power minus x plus c. Therefore, the required general solution of the given differential equation is y is equal to log ex plus e to the power minus x plus c. We remove the mod sign because ex plus e to the power minus x is always positive. Now question number 6 is, find the general solution of dy by dx is equal to 1 plus x square into 1 plus y square. It is in the exact form of dy by dx is equal to gx into hy. There is a two function, product of two function, and one is gx, that is a variable with variable x, that is 1 plus x square, and we consider other as hy with variable y, that is 1 plus y square. So just apply the variable separable method, separate the variables, and then integrate to find the general solution. Okay, so try. So the given differential equation is dy by dx is equal to 1 plus x square into 1 plus y square. So when we separate the variable, we get dy by 1 plus y square is equal to 1 plus x square dx. We just separate the variable, and now integrating both sides of this equation, we get integration of dy by 1 plus y square is equal to integration of 1 plus x square dx. So as we know that the integration of dy by 1 plus y square is tan inverse y, and integration of xn is x to the power n plus 1 by n plus 1. So using this, we have the integration of dy by 1 plus y square is tan square y, tan inverse y, and the integration of 1 is dx plus integration of x square dx, that is tan inverse y is equal to x plus x cube by 3 plus c. This is the required general solution of the given differential equation. Clear? So if there is any question of first order and first degree of differential equation and we have to find the general solution of that differential equation, so if the given equation is in of the form that is dy by dx is equal to gx into hy, so that we can separate the variable, or we can transform it by manipulating by algebraic manipulation, so that we can separate the variable, then we can apply the variable separable method, that is just integrate the separating part to get the general solution of the differential equation. As in the question number 7, that is given differential equation is y log y dx minus x dy is equal to 0. This is your differential equation, and the differential equation is of first order and first degree. Then we try to separate the variables. We write the terms involving y with dy and the terms with x with dx. Okay, as there is y log y dx minus x dy. The term y log y is it with dx and x with dy. So we just separate it according in such a way that y log y comes with dy and the term x comes with dx. Okay, and then integrate to find the general solution. Okay, so let's try. The given differential equation is y log y dx minus x dy is equal to 0. So we get y log y dx is equal to x dy. We just try to separate the variable. So we can rewrite this as dy by y log y is equal to dx by x. So after separating the variable, we just integrating both sides, we get the integral of dy by y log y is equal to integral of dx by x. So now we have to find this integral. So to integrate dy by y log y, we use the substitution method. We take log y as a new variable, that is t. So log y is equal to t, and then we just differentiate it with respect to y. And as we know, differentiation of log y with y is 1 by y. So differentiating log y with respect to y, we get 1 by y is equal to dt by dy. So we can write dt as 1 by y dy. So substituting this value in equation dy by y log y integral we get is equal to dx integral of dx by dx. So for the term the LHS part we can write dy by y as dt, and as we take log y as t, so we get integral of dt by t is equal to integral of dx by x. And we know that integration of dt by t is log mod t. So using this we have log mod t is equal to log mod x plus log mod c. We know that log m is equal to log n is log mn. So apply this logarithmic property, we get log, substitute back the value of t, that is log y. So we get log y is equal to log cx. We already get the solution, general solution of differential equation. Now we just modified the solution by using the logarithmic property. So we get log into log y is equal to log cx. So log y is equal to plus minus cx. Just take the new arbitrary constant, that is small c is equal to plus minus capital C. So log y is equal to cx. Therefore the required general solution of the given differential equation is y is equal to e to the power cx. We take the log from the left hand side to the right hand side, it becomes exponential. So we get y is equal to e to the power cx. Okay. Now question number 8 is find the general solution of the differential equation x to the power 5 dy by dx is equal to minus y to the power 5. So as this is a differential equation of first order and first degree, and it is of the form dy by dx is equal to gx into hy. Okay, so just try to separate the variable. We can easily separate the variable here and then integrate. Okay, so first club the terms with y with dy and the term with dx with dx, and then integrate to find the general solution of this differential equation. Okay, so try. The given differential equation is x to the power 5 dy by dx is equal to minus y to the power 5. So we just separate the variable, write y to the power 5 with dy and x to the power 5 with dx. Okay, so we get dy by y to the power 5 is equal to minus dx by x the power 5. So we can rewrite this as dx by x the power 5 plus dy by y the power 5 is equal to 0. So after the separating the variables, we integrating both side, we get integral of dx by x the power 5 plus integration of dy by y the power 5 is equal to k, where k is any constant. So integration of x to the power minus 5 dx plus integral of y to the power minus 5 dy is equal to k, and we know that integration of x to the power n dx is equal to x to the power n plus 1 by n plus 1, and where n is not equal to minus 1, so we have integration of x to the power minus 5. Here the value of n is minus 5. So we get minus 5 plus 1, that is minus 4, by minus 5 plus 1, that is minus 4. And similarly for integral of y to the power minus 5, so we get x to the power minus 4 by minus 4 plus y to the power minus 4 by minus 4 is equal to k. So just multiply both sides by the minus 4, so we get x to the power minus 4 plus y to the power minus 4 is equal to minus 4k. Therefore, the required general solution of the given differential equation is x to the power minus 4 plus y to the power minus 4 is equal to c, where c is the new arbitrary constant whose value is minus 4k. Question number 9 is, find the general solution of dy by dx is equal to sine inverse x. So as this whenever you solve a differential equation, the first task is to recognize what is the order and degree of the given differential equation. So as the highest order derivative present is dy by dx, so order is 1, and then to find degree, as this given differential equation polynomial with respect to derivative, and the highest power of the highest order derivative term is 1, so degree is also 1. So the given differential equation is of the type first order and first degree. So now we can solve this differential equation by various methods, and the first method we will discussing today is variable separable method. We can apply the variable separable method if the differential equation is type dy by dx is equal to fxy, the function fxy, and if we can separate the function fxy as gx into hy, that is a product of two functions gx into hy, where g is the function with variable x and h is the function with variable y. So if we write a differential equation dy by dx is equal to fxy as dy by dx is equal to gx into hy, then we can apply variable separable method. Why? Because now we can separating the variable. We can write 1 by hy dy is equal to gx dx. Okay, so we just separate the variables. Then we can integrate individually the term with y with respect to dy and the term with x with dx. So when we integrating both sides, we get integration of 1 by hy dy is equal to integration of gx dx, and after integrating we get the general solution of a differential equation. Okay, so as in this question, the question is dy by dx is equal to sine inverse x. So first task is just try to separate the variable and then integrate it to find the general solution. Okay, so I will give you some time, solve this. The given differential equation is dy by dx is equal to sine inverse x. So when we separate the variable, we get dy is equal to sine inverse x dx. So on integrating both sides, we get integration of dy and integration of sine inverse x dx. Now we have to find integration of sine inverse x dx. And we already calculate the value, the integral of sine inverse dx in the chapter of integration by using the by parts method. Okay, so integral of dy is y and integration of sine inverse x into 1 is equal to dx. So here there is two functions and a product of two functions u into v. So whenever we have to integrate the product of u into v, we use the by parts formula, and the formula is integral of u into v dx is u into integration of v dx minus differentiation of v with respect to x into integration of v and then integration of this block dy by dx and integration of v dx with dx. Okay, so we choose sine inverse x as a function u and v as 1. Why we choose in this way? Because if you observe in this formula of by parts, we have to integrate function v and we have to differentiate u, and integration of sine inverse x is, that is a question that is difficult as comparing to 1. So we choose sine inverse x as u and 1 as v. We also use Eilert rule to find which function we have to choose as u and which function we have to choose as v. So after that, we just apply the by parts formula. We get y is equal to u, that is sine inverse x, and integration of 1 dx minus differentiation of sine inverse x with respect to x into integration of 1 dx and then dx. So as we know that differentiation of sine inverse x is 1 by root under 1 minus x square. So y is equal to sine inverse x into x minus integration of 1 by root under 1 minus x square into x dx. So y is equal to x sine inverse x plus integration of minus x by root under 1 minus x square dx. Now we have to find the value of this integral, that is integration of minus x dx by root under 1 minus x square. So we apply the substitution method to integrate this. We take 1 minus x square as a new variable, that is t, and differentiate it with respect to x. We get d by dx 1 minus x square is equal to dt by dx, that is minus 2x is equal to dt by dx. So minus x dx is equal to 1 by 2 dt. So on substituting the value of 1 minus x square is equal to t, minus x dx is equal to 1 by 2 dt, in equation y is equal to sine inverse x into x minus integral of 1 by root under 1 minus x square into x dx, we get y is equal to x sine inverse x plus integral of 1 by 2 root t dt. Okay, we just use the substituting value to get this. Now we integrate 1 by 2 root t dt, and that is 1 by 2 integration of t to the power minus 1 by 2 dt. So we apply the power rule of integration, that is integration of x and dx is x to the power n plus 1 by n plus 1, where n is not equal to minus 1. So using this, we get y is equal to x sine inverse x plus 1 by 2, as here the value of n is minus 1 by 2, so we get t to the power 1 by 2 by 1 by 2 plus c. So the final answer is y is equal to x sine inverse x plus root t by root t plus c. So substitute back the value of t, that is root under 1 minus x square. So we get the general solution of this given differential equation is y is equal to x sine inverse x plus root under 1 minus x square plus c. Okay, good. Now question 10 is find the general solution of ex 10y dx plus 1 minus ex sec square y dy is equal to 0. So at first separate the variable and then integrate to find the general solution. Okay, so try. The given differential equation is ex 10y dx plus 1 minus ex sec square y dy is equal to 0. So we get 1 minus ex into sec square y dy is equal to minus ex 10y dx. So separating the variables, we get sec square y by 10y dy is equal to minus ex 1 minus ex dx. So on integrating both sides, we get integration of sec square y by 10y dy is equal to integration of minus ex by 1 minus ex dx plus log c. That is a constant of integration. So now we have to integrate sec square y by 10y dy and also minus ex by 1 minus ex dx. So to integrate, we apply the substitution method. We consider 10y is equal to u, and when we differentiating 10y with respect to y, that is d 10y is equal to dy is equal to dy, du is equal to dy. And as we know, the differentiation of 10y is sec square y, that is sec square y is equal to du by dy. Okay, so sec square y dy is equal to du. Therefore, the integration of sec square y by 10y dy is become, we replace sec square y dy as du and 10y as u. Now we have to integrate du by u, that is log mod u, and substitute back the value of u, that is 10y. So we get log mod 10y. Now we integrate the second part. For that we consider 1 minus ex as new variable t, and when we differentiate it with respect to x, we get 1 minus ex is equal to dt by dx. That is 1 minus ex is equal to dt by dx. So we can rewrite as minus ex dx is equal to dt. So using this value, the integral minus ex by 1 minus ex dx become integral of dt by t, that is log mod t. So substitute back the value of t, that is log 1 minus ex. So we have the value of this integral, that is integral of sec square by 10y is log 10y, and integral of minus ex by 1 minus ex is log mod 1 minus ex. So using this equation, we get log mod 10y is equal to log mod 1 minus ex is plus log c. We know that log m plus log n is equal to log mn. So using this, we have log 10y is equal to log c 1 minus ex. So on cancelling log both sides, we have 10y is equal to plus minus c 1 minus ex. Therefore, the required general solution of the given differential equation is 10y is equal to c 1 minus ex. Okay. So thank you.